Hello everyone, welcome back to our channel. So Shomu sir, any interesting question today?
A very interesting question actually, Harsha. Let me quickly jump into the problem first because understanding the question is very important here.
Okay.
A ball of diameter 4 centimeter is kept on top of a hollow cylinder standing vertically. Now, which is standing vertically? Obviously the cylinder, right? Now, first thing, whenever I look at a problem, whenever I'm reading this first statement, the question that immediately jumps on my mind is how much portion of the ball is inside the cylinder? That should be an obvious query in everybody's mind whenever somebody is reading the first sentence. Because the ball is kept on top of a cylinder, we know the diameter of the ball, but what about the base or rather the top area of the hollow cylinder? I mean, the ball will go something inside of that hollow cylinder, right? But how much inside? So that should be a query immediately after reading the first sentence. Next, it carries as the height of the cylinder is 3 centimeter. Fine. So now we have the height, but still we need that circle, right? Because if you think about the cylinder out here, this circle is important because that will determine how much of the ball is inside, right? So this height is not answering the question, while its volume is 9 pi. So now, if you already had that query, now you should be able to make a connection, because if you have the height and if you have the volume of the cylinder, pi r square h volume, right? So as soon as you have the height as well as the volume, you can determine the radius. That is the base radius, and base radius will be the top radius also, right? So this part is actually giving me this query. I mean, this will resolve my query, right? So if you are thinking in this way, while you're reading it, to this point, you will understand the connection that is happening in the question. Now, what are we looking for? The vertical distance of the topmost point of the ball from the base of the cylinder. So at the face of it, it looks very scary kind of question. But let's first draw the diagram. Was this question understandable on the basics of it, Harshad?
So sir, when I was actually looking at this question, when you were comprehending this this for us, I actually remembered that this was the exact question. Is it the 2017 CAT question?
Could be. I don't remember, but yeah, possibly, could be. Yeah.
I think this was the very same question in which I also, I was also stuck for a few minutes. Eventually, I left this question.
Okay, you left this. Yeah, I mean, I can understand, because the thing is, if you see, first of all, that query, that how much the ball is inside the cylinder.
Right.
If that query doesn't come to our mind, anyhow, I mean, this question becomes complicated. Also, the vertical distance of the topmost point of the ball from the base of the cylinder, on the face of it, looks a very complicated kind of question, right? On the face of it, at least. So let me just draw the diagram once to explain this a bit properly. So I'll just use some lines and all. I mean, and very well do this freehand. I mean, you won't be able to do this, but don't mind me doing it. So I'm just doing a rough bit out here. Yeah, something like this. And then we have this ball out here, right? Something like this. At this moment, I don't know how much the ball is inside and outside. So I'm just drawing a rough one. So in order to estimate this, I mean, rather, I would suggest you draw this diagram after solving a part of it, which I'm going to solve first. But just for your reference, I've drawn this as of now. So if you look at this particular sentence, I mean, the second information that has been presented, if you remember, the initial query that I had was regarding the, radius of this particular top area of the cylinder, something like that, right? So if you need to determine that, you equate the volume to pi r square h. So you have pi r square, and the h is known to us, so that is 3, and that is equal to 9 pi, right? The pi gets cancelled out, 3 gets cancelled out, so you have r is equal to root 3. I mean, r square is 3, so r is equal to root 3, right? So if the r is root 3, now think about it. What is the diameter then? I mean, diameter of this part I'm talking about. This diameter is what I'm talking about. So this diameter is 2 root 3, right?
Right.
And the diameter of the ball is 4. Now, obviously, I mean, you don't have to draw this to figure it out. The 2 root 3 is actually less than 4, right? Because root 3 is less than 2. If root 3 is less than 2, then twice of root 3 will be less than twice of 2, right? So if 2 root 3 is less than 4, what does that mean? That this particular line, I mean, if you think about this endpoint and this endpoint, if you consider this as a circle, the line connecting these two endpoints will basically be a chord, right, on the circle. So this chord is less than the diameter, implying the diameter should be above this particular line, isn't it? So this is the part that needed to be interpreted. I mean, this is the part you needed to interpret to solve this particular problem. So if you just try to understand what we are trying to solve, what are we trying to solve? We are trying to find the vertical distance of the topmost point of the ball. So topmost point of the ball will be this one, right? Roughly from the base of the cylinder. So we are trying to figure out sort of this distance, right? Now, if we think about this distance, we can like break it into comfortable numbers. For example, height of the cylinder is known to us, isn't it? That is 3 centimeter.
Right.
Also, if this is the diameter of this ball, then this particular point is the center, right? So point here to the center, that is basically the radius of the ball.
Radius. Correct.
So
Correct.
the radius of the ball, or let's say this particular section, is half of this diameter, right? Which is 2 centimeter.
Right.
And since we are trying to figure out this particular distance, all we have left out is to figure out this length. So if I can figure out this length, our job is done. 3 plus 2 plus that will be our answer, isn't it? So what is this length? So let me just take this circle outside. I'm drawing a rough one out here. So we have this line, that is this chord. I mean, not the circular thing, a straight line. So we have a chord out here. We have the center out here. We are concerned about this segment, right? This is the segment we are concerned about. And this is the radius of this particular circle, which is again 2 centimeter. Also, we know the diameter of this. I mean, what is this, by the way? This chord of this circle is the diameter of this base, right? Or rather the top of the cylinder, right? So the radius is √3. So this section should be √3. Is it right? Just simply apply Pythagoras. So you have 2 √3. I mean, if you know the triplet, 1 is to √3 is to 2. So if this is 2 and √3, this should be 1. Or simply apply Pythagoras, √4 minus 3. So this is 1, right? So that gives us this as 1 centimeter. And that solves our answer. So we are looking for vertical distance in centimeters. So that would be 2 plus 1 plus 3. So that would be 6 as our answer.
I am still thinking about what I did at that time in the exam.
No, I mean, I understand. I mean, now it might look a little simpler, but the most important thing for this particular question was the comprehension of it. So when it comes to, so this is a general trend of CAD. Okay. I mean, nowadays I would say even 100%, but even if you consider the overall historical data and stuff, I would still say more than 90% of the questions. More than 90% of the questions of CAD geometry types are given without a figure.
Right.
So the first thing you have to understand is the visualization. So when you are reading it, in your mind, you should be able to visualize the figure, what is happening to some extent. I'm not asking you to exactly draw it on the face of it. I mean, in your mind itself. But what I'm trying to explain is what are the relevant things. So for example, the ball is on top of a hollow cylinder. The first question that should come to our mind is how much of the ball is inside. So for example, it had the diameter of the ball being less than the diameter of the top of the cylinder, then the ball would have fallen down, isn't it?
Right.
So think if that is the case, then the distance, the vertical distance of the topmost point of the ball from the base of the cylinder will simply be the diameter of the ball. So if you don't have to solve anything for that, right? So for example, if this thing would have been instead of 4, if this would have been 3 centimeter, so then 2 √3 is actually greater than 3, right? So if 2 √3 is greater than 3, the ball, this particular ball has dropped down. Something like this has happened, isn't it? So the topmost point from the base is basically the diameter of the ball. So there is nothing to solve for that question, right? So I mean, had this ball's diameter being equal to the diameter of the top of the cylinder, then also it is very easy because this particular point would have coincided here, right? So if let me just draw a rough one. So there would be a sort of a semicircle on top of a cylinder, isn't it? Something like this would have happened, right? Then it would simply be the height of the cylinder plus this would be the radius of the ball, and that's it. So understanding what is happening would be somewhat related to how much curious you are while you're reading the question, isn't it? So for example, when I'm reading this question, okay, let me just take that off. I mean, I change the data, but while I'm reading the question, the first thing that strikes to my mind is, I mean, or rather the first question that strikes to my mind is, how much of the ball is inside the cylinder, right? If that question strikes to your mind as well, when you're reading the second information or the second sentence, you would understand that now we can find the answer to that question that arose in our mind, isn't it?
Correct.
And hence you establish a connection. So by visualization, I'm not talking about in your mind actually drawing a cylinder and actually drawing a ball on top of it. What I'm saying is visualizing that what is happening in terms of the main context. So if the ball is kept on top of the cylinder, how much is inside? So that should be a query even without imagining a cylinder and imagining a ball, isn't it? So that is basically visualization. So when I use this term visualization, sometimes people make a mistake and imagine that I'm trying to draw the figures in my mind. That is not what I'm doing. I'm thinking about the main context out here.
Okay.
So yeah, that's it from my end. A few extra things added. In terms of
No, that was actually required, sir. Thank you so much, sir, for this lovely question, and thank you so much for explaining this in such a simple way.
Thank you, Ashal.
Thanks everyone. Thanks for joining in. Have a nice day.
If you haven't yet checked the full playlist containing this video, then check the description for the direct link. Also, if you enjoyed this video and want to stay updated with our daily questions, tutorials, and problem-solving sessions, make sure to hit that subscribe button and the bell icon to never miss an update. In addition to our daily questions, we also offer comprehensive preparation for CAT and other management entrance tests. If you're looking to excel in these exams, we highly recommend checking out these courses in our website. To get a taste of what our courses have to offer, we invite you to take a free demo. The demo will give you a glimpse into the quality and effectiveness of our teaching methods, study materials, and practice resources. You can find the relevant links in the description of this video. Have a nice and successful preparation ahead. See you in the next one.